Hello, dear students. Welcome back to our math classes. How are you all? I hope you all are healthy and doing well. So, students, I'm your mathematics educator again here with a new chapter and a new concept. And today we have chapter number 16, which is data handling. So, before starting this chapter, first of all, we have to understand what does mean by data handling. So, data means collection of information. So, when we collect information on a particular topic, that it's called your data, and handling means when we interrupt this data, when we analyze this data, or we represent this data by using different methods we have. So let's start this chapter. So in the previous class you were made acquainted with the meaning, collection and tabulation of data. So some methods to represent data pictorially, it's called pictographs and bar graphs, were also introduced to you. In this chapter, you shall learn more about collection, organization, interpretation of data, and you shall learn some new concept which is mean, median, and mode of data and probability. So we already know that the basics of data handling, which we already do in our earlier classes. And in this class, we are going to learn about the new concept which are mean, mode, and median. So let's get started. Collection of data. A collection of facts or figures from which some information can be drawn. It's called data. The purpose of data is collection is understand and explain and analyze the problem cause behind it. We are using data, we collecting data to identify how much we have to analyze, and accordingly we have to proceed with it. So data that we use can be from the data to be used can be of two types. The primary data. The primary data is the one which is collected by the investigator himself by conducting an inquiry of survey. For example, to know the intelligence quotient of the student, we can give them a test and collect the relevant data ourselves. The data so collected will be primary data. So when we collect the data by ourselves only, that is called your primary data. And when we consider the data from another surveys, from another sites, that is called your secondary data. So the secondary data is one which has already been collected by source other than the present investigator. For example, to measure the intelligent quotient of students, we make use of the relevant data. So that is called your secondary data. Next, the observation. So for example, you have 30 students in your class, and the marks of it, so each student marks is your observation, and how many times a particular marks is repeating, that is called your frequency. Next we have variable. The characteristics under study, marks in this case it terms as variable. When we just collected your data, exactly that is in a way. For example, this is your markings for your 30 students. So this is called your raw data. And when you arrange this data ascending order in descending order, then it is called your array. So now we are going to learn about the organization of data. So this data, this given data can be expressed in different forms as given below. First of all, individual series. When the observation are expressed individually, the value of each and every item can be observed separately. It is known as individual series. Individual series can be expressed in the following ways. These are the ways. We representing roll number 1 to 10, heights of 1 to 10 students, roll number 1 to 10, and the same we do with 11 to 20 roll number. So according to the size of the magnitude of height, the height measurement can be recorded either in ascending or descending order. So the arrangement of data in the ascending or descending order of magnitude is known as an array or arrayed data. We already discussed it. When we don't do any change in our data, that is called your raw data. And when we arrange it in ascending and descending order, that is called your array. Now, discrete series. In case of large number of observation, arranging the data as an array is a tedious piece of work. So the data is presented as discrete series. Here the data is presented in the tabular form by writing all the values of the variables. So for example, how many times 125 repeat? 2 times. And we representing it by using telemarks, which we already do in our earlier classes. For 2, we have to represent 2 vertical lines. For 5, how can we represent? 1, 2, 3, 4, and then 5, a diagonal by crossing it. Okay. So 135 is 3 times, so we're representing 3 vertical lines. Such a presentation of data, it's called frequency table or frequency distribution. A glance, the table shows that the minimum height in the given data it's 120 centimeter and the maximum height is 155 centimeter, and that is easy for us to understand it. The difference between the highest and lowest value of the observation is called the range of the data. Thus, the range of the above data is 155 centimeter minus 125 centimeter, that is equal to 30 centimeter. Range is the difference between your highest and the lowest values. Okay. So now measure of central tendency. A central tendency is a figure that represents the whole data. In other words, measure of central tendency summarize the data with a single value, which can represent the entire data. You can see examples of summarizing a large set of data in a day-to-day life, like average marks obtained by the students of a class in a test, average rainfall in an area, average production in a factory, average income of a person working in the firm, etc. So what we understand here, central. Center means center of that particular data. So by taking central tendency, we can understand each and everything about your data. That's why we are using it. And the common thing we use in central tendency, that is your average. Okay. Now, individual observation in a data have the characteristics of showing a tendency to concentrate at a certain values, usually somewhere in the center of the distribution. So for instance, if in a test we find that a very large number of students have scored marks around 70 out of 100, then 70 marks can be considered as your central tendency. Now, three important measures of central tendency are mean, median, and mode. Suppose you want to assess the performance of a particular student, say Prachi, in an examination, then you would like to know if Prachi's marks are above average, above the marks scored by half of the class, and above what most of the students scored mode. Okay, so these are the things. Above average in the ordinary sense is arithmetic mean. Above marks scored by the half of the class, that is your median, and above what most of the students score, that is your mode. So the measuring of central tendency is a way of summarizing the data in the form of representative value. Let us now learn about the meanings and methods of this central tendency. So first of all, we have arithmetic mean. Arithmetic means, or simply known as mean, is the most commonly used measure of central tendency. It is defined as the sum of the values for all observations divided by the number of observations, that is, so what you have to do, this all observations you have to add them together, and the number of observation you have to divide it with them, and you will get your answer, which is your mean. We can also say that mean, it's kind of your average. Okay, so now Dipti scores the following marks in the four tests: 50, 80, 60, 90. So what is the mean for the Dipti scored? So you just have to add these 1, 2, 3, 4 observation and the number 4 divided by number 4, and you will get your answer 70. Thus, the mean marks scored by Dipti is 70. Now, the rainfall in millimeter in a city in a certain week was scored as. So, these are the observations you have, and you have to find out the range of the rainfall, the mean of the rainfall for the week, and the number of days the rainfall was above the mean rainfall. So, for range, you have to subtract from the highest value from the lowest. You have to subtract lowest value from the highest value. So you have your answer 15.1 minus 1.4, that is equal to 13.7 centimeter. Next, mean rainfall for the week is, you just have to add the observations together and divide it with the number of observation. So answer is 9.2 centimeter. Now you have to find out how many days you have the rainfall above 9.2 centimeter. So on 4 days the rainfall was above the mean rainfall, which is your 9.2. So Wednesday, Friday, and Saturday and Sunday is 9.3, right? So I hope so you can understand here how can you find out your mean. Now we move forward. Wait, the mean of a number, or the mean of 6 number is 15. If one of the number is left out, the mean is 13. Find the left out number. So sum of all observation and number of observations. So you have 15 and number of observation. The sum of 6 numbers is missing. So 5 multiplied by 6 is 90. Same you have to do here. That is equal, x is equal to, you don't know x. So what is your x? So x is equal to 90 minus x divided by 5. So 90 minus x divided by 5 will be 5 multiplied by 13, and subtract 90, your answer, which is 65. So the missing number is your 25. Okay, students. Now we have our exercise 16.1. The height of 5 boys in a group are. So find the mean of height. What you have to do? You have to add them these values and divide it with the number of observation 1, 2, 3, 4, 5, and you will get your answer. Find the mean of the first 8 natural numbers. So first 8 natural number 1 plus 2, 3, 4, 5, 6, and 8, and divided it with 8. 3, 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 8, it's 15 plus 8, 23, 23 plus 6 is 29. So 29 divided by 8 is your answer. 3 and we left with 3. So you have to take 30. So again 3.3 is your answer. Okay. The marks out of 50 obtained by a group of students in English test is this. So you have to add them. First range marks obtained by the group and the number of students who obtained less than the mean marks. So that is very easy for you. You can do this. In question number 4, the same process we have to do here. Now, if the mean of 3, 5, 6, 8 and x and 19 is 9, then find the value of x. 3 plus 5 plus 6 plus 8 plus 19 plus x. 1, 2, 3, 4, 5, 6 and that is equal to 9. So 3 plus 5, 8, 8, 8, 16, 16 plus 6 is 22, 22 plus 19, 32, 32 plus 9, 41. So 41 plus x divided by 6, 9. 9 multiplied by 6 minus 41 is equal to x. 9 6 are 54 minus 41 is equal to x. 4 minus 1 is 3. 5 minus 4 is 1. So x is equal to 30. Okay. Next we have the mean of 6 number is 25. If one number is excluded, their mean is 27. Find the excluded number. I already explained you this question in example and very deeply. So you can go there and you have to find out how I solve it and then move forward to this question. Then you have to give a try to it. Now the mean of 8 numbers is 65. If 3 is added to the each number, then find the new mean. So the 8 number mean is 65 and you don't know the numbers, so this what? And you add 3 to each number. If 3 is added to each number means we multiplied x by 3 thrice of it na, then so 65 multiplied by 8 divided by 3, you have your answer. We cannot 65, it's not possible. 33, 8 6 are 58, 6 are 48, 48 plus 3 52 divided by 3. So we have 122. Your answer would be, so find the new mean. 521,703.3 is your answer. Okay, students. So in same way, you have to find out the answer for rest of the question you have in exercise 16.1. Now we have median. Arithmetic mean, as you have seen, is affected by the presence of extreme values in the data. Therefore, it not be truly representative of the whole data. For example, suppose in a shop, the income of 5% is 600, 650, 700, 850 and 5,200. The average of the main is income is given 1600. You can see that out of 5 values in the data, 4 values are much below the mean and 1 value is much higher. So we have a difference in the values that the mean. Thus in the case, mean is not truly representative of the entire data. So in that case, we have to use the this positional measure. So if we take a measure of central tendency which is based on the middle position of the data, it is not affected by extreme values. This positional measure is called the median. The median is the middle value when the data is arranged in order to of the magnitude. It is that value of the variable which divides the data into two equal parts. One part comprises all values greater than or equal to the median value and the other comprises of all values less than or equal to the median value. So if you have odd numbers, so you have to make it by adding 1 to them to get a even number. To calculate the median, arrange the observation in ascending or descending order of magnitude and make use of the following formula. Median, value of n plus 1 divided by 2, your observation, where n is the number of observation is odd. If the number an even number of observation in the data, then there will be 2 observation which fall in the middle. So n by 2 and n by 2 plus 1 divided by 2, where n is the number of observation is even. Following the examples will illustrate the calculation of median. Find the median of the following data. So these are the numbers. First of all, we have to arrange it in ascending order. Then here what we observe 1, 2, 3, 4, 5, 6, 7, 8, 9. So in 9, we just have to consider n is equal to 9. Now n plus 1 divided by 2. 10 by 2 is fifth. So you have to consider 1, 2, 3, 4, fifth. 6 is your median. Okay. Now the following data provides marks of 14 students. So this is an even number. 14 divided by 2 is 7. 14 plus 1 divided by 2 is 8. Okay. 7 plus 1 is 8. So now you have to take two medians, the 7th observation and the 8th observation. So 7th observation is 51 and 8th observation is 53. Add them together and divide it with 2. You will get your answer, which is 52. Okay. So in such a way, you have to calculate your median. And next we have mode. Mode is very easy. Arithmetic mean is good measure of central tendency when a person wants to find the average value of an variate. Example, average cost, average marks, average heights, etc. Similarly, median is good measure even when extreme values occur in the data or in those cases where the phenomenon under study is not capable of measurement in definite units. So intelligence and health, etc. So in this case, what you have to do, if the shopkeeper finds the mean of the shoes sold in a day, he gets mean, this is the mean, 8. On the basis of the mean, if the shopkeeper orders for 8 pairs of shoes of each size, then he will not be able to meet the needs of customer demanding shoes of size 8 and 19. So, thus mean and median are not appropriate measure of central tendency in such situations. Here, mode is the most appropriate measure. We see what happened when we consider the mean and when we consider the median. So, the same thing is repeating here. Then greater than 8, greater than or equal to 8, then also he does not meet the needs of all customers. So then we have to take our mode word is derived from French word la mode, which signifies the most fashionable. So mode of a set of observation is the value of the observation that occurs most frequently. So how many, the larger frequency we have for a particular observation, that is your mode. For example, find the mode of the following data. So 1, here we see that number 6 is repeated, have more values of more frequency. So here the value of 6 occurs the maximum number of times. So you can simply say 6 is the mode of the given data. So in mode, you just have to consider that the number which have maximum number of frequency, that is your mode. 16.2, find the median of the following data. So in median of the following data, first we have to find out 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 1 divided by 2, that is equal to 5. 1, 2, 3, 4, 5. 22 is your median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So again 7th. 1, 2, 3, 4, 5, 6, 7. 7th is your median. So accordingly, you have to find out your median. Okay. Next, find the mode of the following data. 41, 41, 2, 1, 2, 40, 45, 45. So 45 is the mode of this data. For calculating mode, there is advice from my side for you, that is, you have to arrange your numbers in ascending or descending order accordingly, and then you simply get your answer, which is your mode. So find the median of the first 20 whole numbers. So you have to take your first 20 whole numbers. It means 20 upon 2. First we have 10. In this case we have, so here we have to take two terms, which is your term 10th 11, 10th term and 11th term. If you have your counting 1 to 20, so you know that at 10th place you have 10 and 11th place you have 11. 10 plus 11, so it is 21 divided by 2. So your answer would be 1.5, 10.5 something. Okay. Now find the median of first 17 odd numbers. So same process you have to do here. 17 plus 1 is 18. 18 divided by 2 is 9. So your 9th term would be your 9 only. So 9 is your median. Okay. Given below are the weights in kg of 15 children. Find the mean, median or mode. So 19, 29, 20. 20 is the mode, I think. 1, 2 and 21. 21 is the mode. Now, students, you already know how you have to calculate mean, mode, and median. So, in this exercise, the rest of the question are related to mean, median, and mode. So, you can do it yourself. Now, we have our bar graph, and bar graph, we already understood what we have to do here. In class 6, you have learned that a bar graph is pictorial representation of numerical data by a number of rectangles of uniform width erected vertical or horizontal with equal spacing between them. So you have learned how to read and interpret bar graphs and also how to draw bar graphs. The following table gives the number of students in school during the last 6 years. This is your information and you have to represent this data by using your bar graph. So first of all, you have to make y-axis and x-axis. On your x-axis, your year information and your y-axis should be your scale. Now in 1996 and 1907, we have 880. So this is your answer for this. You have to make your first paragraph till 880. Next, you have to make for 960. So 960. In same way, you have to just draw your bar graphs according to your given data. The average daily temperature for a week. Again, we have a table which we have to represent. So what you have to do here, you have to make your y-axis, I-axis. Your scale should be the difference of 10. The difference between 10 and 20, we have 10, 30 and 20, 10. And then you have to mention your data by using your bar graph. So on Monday we have 25 temperature, 25-degree temperature. So you have to represent in way. One thing you have to keep in mind, the difference between your bar graphs should be same and the width of these bar graphs also should be same. That's it. And now you can easily represent your data on your bar graph. Now composition of bar graph. Composite bar graphs or double bar graphs are drawn to compare a phenomena or characteristics of two different data. For example, suppose we have the data regarding marks of 5 students for quarterly examination and also the data for marks in half-yearly examination for the same 5 students. In double bar graph, what you have to consider that you always take this bar graph to compare something, and in that case you are representing two data in a same bar graph, and the difference between two bars you don't have. After two bar graphs you have to maintain a particular difference, otherwise the same procedure we have to follow here for the bar graph. Now we have 16.3, the population of a 4 major cities in India in a particular year is given below. So this is the data you have. You just have to show the bar graph. So in this question you have to draw your bar graphs. And next we have probability. So in this exercise you just have to make your bar graphs by considering that first of all you have to make your x-axis, y-axis, a scale, and then you can easily show your data. Now we move forward to the next concept, which is probability. Probability means a random guess. Okay, when you toss your coin, you don't know which is your outcome, your head or toss will come. So it means that it's a suggestion. Okay, so in a day-to-day life, you often comes across the words probability. Probability means chance, probability, etc. For example, probability it will rain or not. He has a good chance of winning the match. There is a little probability of his regaining health. So you can say random guess, any chance. So that is called your probability. These words convey a sense of uncertainty of happening of the stated event. For instance, in the first statement, one cannot say for sure that it will be rain today. So when we don't have the surety for 100%, when we are little bit of chances like 50%, 60%, 70%, that is called your probability. Now, in probability, what we have to going to learn, first of all, you have random experiment. When you toss your coin, you have two random experiments. One is head and the second one is toss. That is called your random experiment. An experiment whose possible outcomes are known in advance but none can be predicted with certainty. It's called a random experiment. Outcomes of a random experiment are called events. For example, in a tossing of a coin, getting a head is an event. In throwing of a die, getting an even number is an event. So when you do something and the chances of further outcomes we have, that is called your event. Now, each of these outcomes is said to be favorable outcomes to occurrence of A. It means when you toss your coin, it means it would be a head or it would be a tail. So these are the favorable chance we have. We don't have another kind of outcome in this point. So what is probability? Here we are not going to define probability but simply give you an idea of what probability is. You have seen that in a toss of a coin, the two possible outcomes are head or tail are equally likely. Chances of getting head or tail are. So half and half. So we say that probability of getting head is equal to the probability of getting tail. is half for each. Now we have our exercise 16.4 where we have to deal with probability. State whether the following is impossible, may happen, or is certain to happen. It will be a cloudy tomorrow. So it could be the probability where they have some chances. It have some chances. Now the sum of angles of this triangle will be 180 degree. That is certain to happen. We know that the sum of all three angles in a triangle is always equal to 180 degree. He will come to my house in the evening. So maybe happen. So this is maybe happen. H certain to happen, and this is maybe happen. So accordingly, you have to classify these statements in the categories of impossible, may happen, or certain to happen. Now write the possible outcomes for the following random experiments. Tossing a coin, you have head or tail. Throwing a die, you have numbers 1 to 6. So accordingly, you just have to write down the random experiments for the given possible situations. If a die is thrown, which outcomes are favorable for getting an odd number? So we already know that we have three odd numbers in this, 1, 3 and 5. So the chances for this is 3 by 6, and when we simplify this fraction is half. Next, we have a box contains 4 balls, red, green, white and black. If you draw a ball at random, what is the probability that you will get a red ball? So 4 ball, 1, 2, 3. So getting a red ball is 1 by 4 and a white ball is also 1 by 4. So students, accordingly, you have to do the rest of the question you have in your exercise 16.4, and this is the end of your chapter. I hope so students you like this chapter and understood it very well. This is not the end of your chapter. This is the end of your syllabus as well. So this is my last class with you. Now I'm going to meet you in your higher classes. So what you have to do now, you have to start preparation for your examination, and I'm going to meet you in higher classes. Till that, bye bye. Have a good day. All the best for your exams.